Welcome to this lesson on plotting points in the polar plane. Hopefully you will recall that a point in polar form looks like r, theta. Now just to bring something to your attention, in older textbooks and some professors, you might see the use of a semicolon here instead of a comma. Where the use of the semicolon comes from is a long time ago when many people thought a point in polar form looked too much like a point in rectangular XY form. So many textbooks and people will use a semicolon here instead of a comma just to differentiate and draw attention to the fact that we do have a polar point. The r, of course, represents the distance of the point from the pole, which we know as the origin in the Cartesian XY plane. Theta represents the measure of the angle formed by the terminal ray and the polar axis, which is really, as we know it, the horizontal axis or the x-axis in the Cartesian plane. The polar coordinate plane looks very different from the Cartesian plane. Notice you have a horizontal and a vertical axis. Since our points here are in terms of r and theta, it would be incorrect to refer to the horizontal axis as the x-axis and the vertical axis as the y-axis, because there are no x's and y's in the polar coordinate plane. Notice how you have these concentric circles, which will count out your r value for each polar point. We also have it looking very similar to a unit circle in that our angles go from 0 to 2 pi. Now in the Cartesian plane, any point has only one pair of coordinates to describe it. For instance, the point 4, 5 in the first quadrant, that's the only way you can name that point so as to correctly describe its location in the first quadrant. In the polar plane, however, a point can have infinitely many pairs to describe it. So for instance, if I were to have a point right here, which is the point 1, 2, 3, 4 pi over 3, there's going to be other ways to identify that same point. Because instead of thinking of this as angle pi over 3, I could think of it in terms of the negative coterminal angle, negative 5 pi over 3. The point would still lie in the same place. It's just now represented with a negative angle instead. This is something you're going to see in the next video when we discuss how to represent a polar point with different representations. We're going to focus here, though, on how to plot polar points in the polar plane. Let's start with letter A, which is the point 2 pi over 3. If you think of starting with the angle first, pi over 3, and since r is 2, we're going to go 2 circles out, 1, 2, and this is where our point will be. Our next point, B, is 3 negative pi over 6. Once again, let's do the angle first, so we know we need to go down. Negative pi over 6 lies in the same location as 11 pi over 6, and we're simply going to go 3 circles out now from the pole. 1, 2, 3. So it lies right here. Point C is 3 11 pi over 6. Well, we just said 11 pi over 6 is coterminal with negative pi over 6. So point C is going to lie in the exact same location as point B did. Starting with point D, you're going to notice we now have negative r values. So let's talk a bit about how you handle that. Once again, we're still going to go to the angle first. So for point D, we're going to go to pi over 2, which is on the upper part of the vertical axis. But since it's a negative r value, instead of going in the direction of that angle, we're going to go away from it. So once we're at pi over 2, we're going to slide to the opposite side, and our r value, since it's an r of negative 1, it's going to be 1 circle out but going away from that angle of pi over 2. Point E is -4, 3 pi over 2. Once again, we'll go to 3 pi over 2, our angle first. But now since we have a -4 for our R value, we're going to slide 4 circles out away from 3 pi over 2. That puts us up here heading towards positive pi over 2. Point F is -2, 4 pi over 3. Once again, we go to 4 pi over 3 first, but since we have a -2 for our R value, we're going to slide away from 4 pi over 3, and notice we land right on top of where point A was. Our last point, G, is -3, -pi over 4. We do -pi over 4 first, which we know lies in the same location as 7 pi over 4. But since we have a negative R value, we're going to slide 3 away from -pi over 4. That puts us right here. Your knowledge of how to plot polar points is going to come in handy in the next lesson when we talk about how to create multiple representations of a single polar point.